I'm Amanda Johnsen, Assistant Professor of Nuclear Engineering in Penn State's College of Engineering. Nuclear engineering applies the principles of radiation science and nuclear physics in areas such as nuclear energy, nuclear medicine, nuclear safety, radiochemistry, detection, the plasma sciences, and more. Nuclear engineering students learn how to combine the fundamentals of mathematics, chemistry, physics, computer programming, and engineering sciences and apply that to the theory, practice, and experimentation within many applications, including nuclear power generation. Nuclear engineers not only work in electricity generation, but they also have careers related to treating disease, safeguarding food supplies, nuclear forensics, operating nuclear energy systems, developing regulations to ensure safety, and facilitating exploration, among others. Penn State Nuclear Engineering alumni service and maintain the systems essential to our everyday lives, such as medicine, food and agriculture. Nuclear engineers are helping to use nuclear energy for sustainability and to address climate changes as a carbon-free energy source. Many go on to graduate school, after which they work in academia, industry, or at research laboratories. Penn State's Ken and Mary Alice Lindquist Department of Nuclear Engineering collaborates with the Breazeale Nuclear Reactor, the longest operating licensed research reactor in the country. Faculty and students alike use this reactor to conduct research that propels the field forward, including the use of neutron science in materials and life science research. One of the reasons Penn State is a great place to come for nuclear engineering is the Breazeale Nuclear Reactor right behind me. This reactor is a national resource, and students can have the opportunity to become operators, but also to use the neutrons that the reactor produces as a part of research.
What I love about being a nuclear engineer is just the opportunity to interact with people, to solve problems, and to really work in a global context.
The nuclear engineering field is growing pretty rapidly. It used to only be a power engineering field, but now we have a lot of ties into medicine, materials, labs, and other places, even propulsion as the space industry starts to come back.
I kind of knew I always wanted to be in STEM. I saw The Incredible Hulk, got hooked, saw Iron Man, and Iron Man became my favorite superhero. And I did a little bit of research and found out that his arc reactor that powers his suit was basically a nuclear reactor. So I was like, I want to build the Iron Man suit. I'm going to become a nuclear engineer, and here I am.
One of the aspects I love most about being a nuclear engineer here at Penn State is that our class sizes are typically smaller than most larger engineer classes. So you really get to know everyone in your major on a one-to-one basis, and you make all these meaningful connections with the people around you.
There are a lot of research for undergrads in nuclear engineering. So if you talk to your professor and you hand in your resume, they would more likely to accept you doing their research.
As a nuclear engineering student, you can actually have the opportunity to work part-time at the reactor on campus. You can become an auxiliary operator, so you can help prepare samples, load them into the different test tubes, help move the reactor across the pool, rotate it. It's a really great experience. You can also become a reactor operator there, so you can actually see all of the stuff you learn in your class being applied to the reactor as you control it and move all the different control rods.
One of the things that we're trying to figure out is how to prolong the life of plants in the United States. What kind of new fuel products to use in the industry so that we can actually get better efficiency. And frankly, we're looking to really shrink the size of the reactors.
You know, one of the big things that we're working on are what we call SMRs, or small modular reactors. The small modular reactor allows us to build reactors at a fraction of the cost of a traditional reactor and still deliver safe, clean, and reliable energy.
Me personally, I've always had a passion to leave the world a better place, and I can't think of a more effective way than finding a way to deliver clean, safe, reliable energy to countries and other places to raise the standard of living to something that we in the United States take for granted.
We all, as engineers, kind of strive to make the world better in some way. Being a nuclear engineer specifically, climate change is a big thing, and I think nuclear energy is going to be a big part in combating climate change.
Penn State Nuclear Engineering is really special and important to me, because Penn State Nuclear Engineers used to have a program that taught high school teachers all across the Commonwealth about nuclear science. And as a part of that program, I got to come visit the Breazeale Nuclear Reactor as a high school student. And that really started me on the road to being a nuclear engineer. And so now I have the privilege of being here to teach the next generation of Penn State nuclear engineers.